Welcome to the University of Vermont's Central Heating Plant Shutdown Week. As a part of the physical plant, the Central Heating Plant is responsible for providing the campus with hot and cold water, heating and air conditioning, and many other services necessary for daily life on campus. In order to maintain all of these services, once a year the Central Heating Plant must perform a campus-wide shutdown for scheduled maintenance. During this time, the central systems are repaired, inspected, and improved to ensure that the plant can continue to operate flawlessly. While the university's graduates and faculty are celebrating the completion of another academic year, the physical plant staff is hard at work behind the scenes preparing the central systems for the yearly shutdown.
Hi, my name's Ray Donor. I'm the supervisor for the utility zone, and we're going to be talking about what we do during shutdown here at the central campus. We're out in front of the central heating plant right now, and during our 1 week shutdown we shut our boilers down and we do maintenance on them. And on top of that, we do all the maintenance in our steam vaults on campus. At this point in time, we have about 40 vaults we pull maintenance on. Part of the maintenance is we go in and make sure all the valves are operating, all the trap stations are operating. If they're not, we replace them. We pack the valves. We also have about 24 steam stations in the buildings on campus that we do maintenance on also. And we have about 6 miles of high pressure steam piping underground, about 1,000 steam traps that we're doing maintenance on during the shutdown, and thousands of valves that we're doing maintenance on during that week. So by us doing that, even though it inconveniences some people during that process, in the long run, we're saving the campus a lot of time and money by doing this.
Sal Chiarelli, I'm the Director of Physical Plant here at the university. My department's in charge of all the operations and maintenance of the university buildings and systems. So we have about 170 employees, and we handle everything from the grounds, landscaping, all the way to the central plant. The purpose of the annual plant shutdown is to do preventive maintenance and repairs and inspections to our major utility systems, the chilled water and the steam system, so we don't have unexpected shutdowns during the course of the year. So it's like doing preventive maintenance on your automobile, so you don't have a breakdown somewhere down the road on a cold wintry night. So you want to make sure that we don't have those shutdowns when you least expect it. We have a lot of research going on. We have students that need to have the temperature control in their rooms and classrooms. So this has to be uninterrupted service, and the shutdown allows us to do the inspections required by code, as well as do maintenance of valves and equipment and boilers and rotating equipment that you would normally not be able to do unless the system was down.
As far as shutting the plant down, we do that normally right as soon as the last graduation ends. As soon as the last guy walks through the stage, we start doing that shutdown. It requires probably a group of 8 to 10 people all throughout campus to do it, because not all of them, but most of the buildings have small satellite boilers in the buildings. So what they do is they'll get all those boilers started up when the buildings that you need heat or steam, they'll get those boilers started up. They'll start closing valves and stuff that go to that we feed the buildings. They'll start closing valves out there and manholes and stuff also. And we'll start closing valves in the central heating plant as soon as all the satellite boilers come on and all the guys report back to us saying that we're good to go. We'll close our big steam valves off to north and south campus, and the satellites right here in essentially the Davis zone. And then we just throttle back our boilers, let them go down. As soon as the boilers go down, we open the vents, let those vent, shut down all our pumps, shut down the chillers, and pretty much there'll be nothing running inside the central heating plant whatsoever at all. Yeah, it's generally 3 to 5 days, and during that time we have guys come in, they borescope the tubes in the boilers, and they make sure all the structural integrity of the condensate and the DA, all the pressure vessels and stuff like that. And that's generally where we do if we have any big repairs to do, shutdown is the time we do the big repairs.
The shutdown allows us to add new equipment in couple of years ago, we put in a large air and dirt separator on the chilled water system, which allows us to have a more efficient operation of the chilled water system. That could only be done if the system is down, because you have to cut into the piping. So we take advantage of the shutdown to do some of these major modifications for energy efficiency and improvement of the operations.
All employees involved with the shutdown maintenance must undergo special training provided by UVM's Training and Compliance Office. The training prepares them for any eventual hazards that they might be exposed to in steam manholes and confined spaces, and instructs them on the importance of safety while working around steam. After training, the employees are ready to begin shutdown maintenance. In supplement to the central heating and cooling system at the central plant, there are several additional boilers located in major buildings across campus that provide backup heating and cooling for the campus when the central plant cannot. Before the central plant can be shut down, these boilers must be fired up. Once the satellite boilers are online, the entire central plant is ready to be shut off so that the lines can cool in time for maintenance. At 6 p.m. on the Sunday of graduation, the main boilers are shut off, the steam lines drained, and everything is powered down. On the following Monday, the lines and steam stations are cooled down enough for maintenance. Workers begin entering the vaults and manholes, as well as building mechanical rooms to begin the maintenance. When the maintenance is completed, the central heating plant is ready to come back online for another flawless year of service.
We're checking all the valves, steam valves, adding to them, if need be, tightening down the ones that don't need more packing in them. It's a process done every year, campus-wide. Underground, above ground, in buildings, wherever there's a steam valve, it gets done.
A lot of people that buy these valves don't pack them every year. So the metal mesh type graphite is put in to last longer than the rope type. But with high pressure steam, we can't really afford to let them go that long. You know, some people will buy these and put them in and leave them in for 15 years.
Yeah.
You can't afford to do that with high pressure steam.
Yeah.
It's asking for problems.
Right.
But to enter a manhole and tighten a bonnet is, you know, it's more work than you want to do when the steam is on and it's 135 degrees in the vault.
Every other year we change the traps out. We do South Campus this year, North Campus will do next year. And there's 2 trap stations in case one fails, and then the other one will take over. We put these tags on them just to let us know what's been done and what hasn't been done. We change colors every year. Next year we would take this whole bonnet off, and we take all the packing out and repack it with everything new. And that's good for 3 years. We just come again and tighten it in just to seal it if we needed to add, but we wouldn't pull. About every 3 years we pull it all out and put all new packing in.
Startup is essentially the opposite. As guys go out there to campus, they shut all those satellite boilers down. They'll open valves back up. They'll call us up, and actually guys will stay at the buildings. We'll get boilers online, and it usually takes us, it's probably an overnight issue where we'll fire our boilers up, and we'll actually just recirculate the water right here in the plant between the boiler and the pressure vessels, and just recirculate that until it gets heated up until we get to a point where we can safely make the amount of steam that the campus needs. Once we get up to that point, we open the valves up, we start feeding the campus with steam, and the guys will stay in the buildings until all the until where the high pressure steam goes into the buildings to the low pressure steam stations. They'll stand by those, make sure those are operating correctly. They'll make sure the building is getting the appropriate amount of steam and at the right pressures. And then they'll shut everything down, and we're essentially back up again.
When we start it back up, we position different people at different manholes. We open a drain on the steam side, so if there's any water ahead of the steam, it comes out. And then when the steam gets to that point, they shut it and let the traps take over.
And we'd have failure.
They wouldn't work.
Well, eventually the whole system would start to break down at times when you didn't want it to break down.
In rare occurrences, if we didn't do it, you could actually physically blow the steam lines right out of the ground.
We wouldn't be able to produce enough steam for what we needed it for like the research and the building heat, and right now for the chill, we use steam for chilled water.
One valve fails, we may have to shut the entire system down.
If we didn't do the shutdown, we would be looking at a lot of people crossing their fingers, hoping things didn't happen.
We like to keep it clean. We like to keep it maintained. But we live here. Right. We live here. We work in this place every day.
Right.
As a result of the strict attention to detail and hard work of the staff, our campus system is able to operate at a very high efficiency. In a central heating system, the percentage of condensate that is returned to the boilers for reuse is a good gauge of a plant's overall efficiency. Experts normally accept around 60% condensate return as a reasonable number.
You're heating water up and you're making steam, and that steam goes out to the building and does its work. And when it turns back to condensate, which is a water form, it's still hot. It's not 50 degrees, it's like 160, 170 degrees. So every pound of condensate you get back, you have all those BTUs stored in there, as well as it's already treated and it's got chemicals in it. So, it picks up impurities along the way, and it is a little bit corrosive. So we have to make sure that our chemical treatments are proper. But the more condensate you could return, the more efficient your plant operation is. There's less makeup water used, which has to be heated up, because that's coming in from the lake ultimately to the water towers and into our plant. So condensate return is a big factor in efficiency of plant operation. So that's why we look at it very closely and try to get as much back as we can.
Our condensate return is up in the high 90s, and that's very unheard of, especially on a campus this size. And we've actually had consultants come in and tell us there's no way we're getting that amount of condensate back. Then they'll come in and they'll do a survey and they realize that we are getting that amount back, which is very unheard of on a campus this size. Yeah, it's amazing.
So I've been here for going on 14 years next month, and we've actually reduced the steam load and steam demand, even though we've added over 600,000 square foot to the campus. So I remember on a cold, wintry night, there was 150,000 pounds per steam per hour being used routinely in those cold nights. And now we're the same type of night. We might be up around 120, 125, and that's a reduction in steam demand with the increase square footage and increase usage of the buildings. It's not bad to use energy, you just want to use it efficiently. Right. So that's the way I look at it. It's like energy is a good thing, it's helped us get to where we are today, but you don't want to waste it. You don't want to use it inefficiently. We try to continuously improve everything we do. We try to constantly think about technology and resources that are available. We network with a lot of peer organizations. That's one thing that's nice about higher ed. You're sort of in competition, but not really. You're able to tap into other people's experiences. So we have a good network of people out there, especially in New England. The bottom line is to try to make the place better and better every year, with different forms of, currency, which is technology and ideas, and listen to people and let them do a good job for you.